Hello guys, so hopefully in this video I can teach you guys how to make this, where the ball will go wherever you want it to go. And for this example I have it go to this green pad over here. And no, this has no sort of tweening, no sort of Bezier curves or anything like that. This is just some physics and basically some velocity, and it's all using the Roblox physics engine. So really, there is no sort of manual coding going on. It's just letting the game engine do all the work. And so yeah, all right. So first things first, especially when you're trying to tackle something relating to physics, is you should draw it out, or you should try and map it with a painting program. So right here I have MS Paint, and for this problem we have is we want to find the amount of velocity we need. And to get velocity, we can use an equation called a kinematic equation. And these equations are basically the groundworks for physics, and it will tell us like how different variables react with each other. So right now, one of the equations has delta x, which is just like uh, what is the starting point and what is the ending point. And then we have our initial velocity, which is called v naught. Then we have time, which is just like the amount of time it takes to go from one point to another. And then we add the half of acceleration, which is the amount of velocity per second, or the amount of velocity over time. And then we have our time again squared. So what does this mean? So we have our velocity, we have our change in position, we have our time, we have our acceleration. How are we supposed to find velocity out of this? So what we can do is we can basically isolate this velocity by just doing simple algebra. So we can subtract this term on both sides, and we will be left with this, or I guess I'll write it this way. So the delta x stays the same, and then we just subtract this over, and we get this, which is equal to v naught times t. And then we can just divide everything by t. So we get v naught is equal to delta x minus 1/2 times acceleration times time squared over t. And this will be the equation we use for our little script. So let's start off by our constants, because acceleration will just be gravity. Uh, any sort of horizontal motion has no sort of acceleration because there is no sort of air resistance in the Roblox, so we don't have to worry about that. And for delta x, that is just going to be the direction we want it to go, from start to end, and we already know that. We also have time. uh, we're going to specify time ourselves. For this example, I think I'm going to choose 1 second. So let's start off with our constant gravity. So, and I'm gonna make this a vector 3 because the velocity is gonna be a vector 3 in the end. So it's much easier for it to be like this. And this is one way of doing it. You could also do it if you don't want to add the zeros. You can just do y-axis and then times for specific gravity. I personally find this cleaner, but a lot of people don't know what vector 3 y-axis is, and it is kind of theoretically slower because it's multiplying instead of setting it, but it's really up to you. And then since our projectile is in replicated storage, I'm just gonna make a variable for that. Always try and get code and get practice, because you never know never know when this code. It's always uh, it's good practice to do good practice. I don't know how to explain it further. Alright, so we're gonna make a function, and this function is gonna basically give us the velocity we need. So we're gonna call it get velocity, and this is just gonna be a function to this. So it's gonna have the parameters of x, acceleration, and time. And you know, it although it is back practice to have single letter variables, when we write out the equation, it is 10 times easier to read with just letters for variables. So we can just copy this directly. We can do x minus 1/2 times acceleration times time squared, and then all over t. And that's basically it for our math part. We don't all the rest is just applying the velocity. So let's actually, yeah, let's make another function for actually applying that velocity. So let's do go to targets. I like that one. And then we're gonna have our parts. We're gonna have, oh yes, we're gonna have our target, but I'm gonna name it goal position, parts, goal position, and then our time taken. And I would use time, but time is already a keyword, so I mean you can't really do anything. So now that we have this, we can get our velocity, and then we can input, or we don't have x, right? We need a direction, and that direction is just gonna be the final position minus the initial position. So our direction, or our x, is gonna be the final position, which is our goal position, and then our initial position, which is the part's current position. And then with that, we can just put this here for x, and then for acceleration, we could put our gravity we have. And we also have right here, the workspace, it doesn't have gravity as negative, so we have to add the negative ourselves. And then and then for time, we can just have our time taken here, and this will be our velocity, and this will give us a vector 3 because it most addition or multiplication or whatever with vector 3s usually works, and squares also works fine. It's just gonna square the x, y, and z. So all of this should work correctly. It shouldn't give us any errors. And if you want to know more on why we can let these be a vector 3 and not a number, you could say that if we want to solve for one component specifically, so let's say the x is gonna be the exact same thing, except the only thing that changes is that the direction is gonna be, it's still the x direction here, but it's gonna be the x direction, and the acceleration is gonna be the acceleration of x. But when we do vector math, all this is gonna be sorted because for the x part, it's just gonna multiply with the x-axis for all the other vectors. So for acceleration, our gravity is 0, and then it's gravity and then 0. It's for the x is just gonna use this, and then for y it's gonna use this, and then for z it's gonna use this, and it's gonna do all that like simultaneously. So you're not gonna be able to see it, but that's basically what it's doing. It's splitting it up into components, and then we can. That's basically what going into 2D and 3D physics is. You just split things into components, and the vector math for Roblox does that for us very, very nicely. So we just have to apply or set the velocity here, and then for our little effect, what we can do is I made a while true loop, and then I'll just wait a little bit. And usually, when you have constants like this, you want to make a separate variable for them. So let's do loop wait, or yeah, let's just call it that. Or we could call it frequency too, or let's do period. Whoa, it's kind of weird. Okay, so then we're gonna have our new projectile. And it's just gonna be a clone of the one we already have. We're gonna parent it to the workspace, and we're gonna make it go to this target. So we're gonna put in our projectile. Ooh, our goal, which we haven't had initialized yet, our goal part is in workspace. It's called goal, and then we can just put the position here. And then for time taken, we could have it a constant too, but if we wanted to change it, change it based on the amount of distance to make it so you don't have it going super fast or super long. You could also have it dynamic, but for my case, I'm just gonna have it be constant as well. So you have that there, and yep. Let's see if our code works. And yeah, works first try. And if I move this goal, it's gonna realign itself. And you see, when it's super short, it's gonna take that sweet time in the with the y velocity. But if it's super far, it's not gonna use y that much, and it's gonna use, or actually no, because the only thing that's changing is the x and z, because the only thing that changes time is the y velocity. And it's actually something you learn in physics, that no matter if you drop something or you launch it forward, they're both gonna fall at the same time, because the only component that changes time is the y velocity, which is pretty cool. So yeah, so we have this. It's pretty cool. I hope you guys enjoyed it. I hope you guys learned something new, and you know, I love making these videos. Okay, I love teaching you guys. So if you guys have any sort of suggestions or any sort of things you want to have a video on, you can just tell me in the comments. I'll be glad to do it. Okay. Well, that is all, guys. I'll see you guys. Peace.